Here's an example of doing Gauss-Jordan elimination. That is elimination that goes all the way to the reduced row echelon form. And the simplest case is where you end up with a unique solution. You don't do anything necessarily different until the very, very end, but it's certainly easier to deal with the very end of the process when you get a unique solution. And I'll do another example. We'll definitely talk a lot about what happens when you don't get a unique solution, but we haven't completely mastered that yet, certainly. So we suppose we have this system of equations, 3 equations and 3 unknowns, and we immediately write down the augmented matrix for that system. And we need to be real careful to get the numbers right. I think I was careful enough there. And what we're going to do is we're going to go ahead and proceed with elimination. Now I'm going to just copy and paste. We don't change the first row, so I might as well just leave that there. And then what kind of row operations am I going to need to do? I'm going to need to take twice the first row and plus the second row. And that's going to be the new second row. Okay, so let me just go ahead and copy some of that over. So here's the first row. Now again, if you don't feel like you need to do this much scratch work this explicitly, you don't have to do this much, but I just wanted to go ahead and do a bunch. Let's go ahead and copy and paste that again. And now, now I want to just have that second row. Okay, so there's the 2 rows. Alrighty, and now I'll just go ahead and copy that to put in a blank. Okay, so I'm just going to add those together, and I'm going to get 0, minus 2, minus 4, minus 12. So that's what we're going to put in here. Now again, if you can do some of that in your head, that's cool, and I'll probably do some of it without so much scratch work. So the next step would be 3 times, let's say minus 3 times the first row plus the second row. We could express that as subtraction, but it's actually easier to deal with negative numbers and then adding. Okay, so let's take this top row here. Oh, it doesn't seem to want to do that. I don't think it can copy part of the matrix. So let's once again take that guy, but then triple it. Okay. Oh, sorry, plus the third row. You probably was wondering why I was manipulating the second row again. Plus the third row. Okay, so we'll copy and paste the third row in. Oh, and I didn't multiply by minus. Okay, let me stop for a second and make sure I'm doing the right thing. Okay, so minus 3 times this first row. This is the row we're using as a tool. Okay, and then plus that third row. And I'm just going to put it in place here. I'm not going to do it in the scratch area. 0, minus 8, minus 13, minus 36. Okay. So, almost done with the forward phase of elimination. So now I've just got a new copy of that. And now I'm going to take 4 times the new second row here and subtract it from this row. Okay, so that's going to be, let me just do, instead of doing this style where I write out the whole rows, I'm just going to do the relevant scratch calculations. Minus 8 minus 4 times minus 2, that's of course 0. So that's going to be 0. And let me blank these out too. These are ready to fill in with a new row. Okay, now I'm getting, and the next calculation would be minus 13, whoops, minus 13 minus 4 times minus 4. So that's plus 16, so that's going to be a 3. Okay. And then minus 36 minus 4 times a minus 12, that's 12. Oh yeah, this was equal to 3. Okay, so that's equal to 12. Okay, so what was going on there, I just didn't do quite as much scratch work. I was taking minus 4 times this row and adding it to this row. Or in other words, taking the third row and subtracting 4 times the middle row. Okay, so Now's the stage where we switch gears and we try to do reverse elimination. This is almost in row echelon form. According to me, it is. According to the book, you'd have to make these pivots equal to 1. But you don't have to do that if it's not convenient. Whatever it is convenient, though, go ahead. So let's go ahead and go away. There we go. Okay. Let's go ahead and... Uh-oh. Oh, crap. I accidentally deleted the latest version of the matrix. Okay, this would, but we have the numbers. It's 0, 3, and 12. Okay, that's why it was so strange. Okay, now we're good. So, we're going to divide this by 3 because it's convenient, and it doesn't give us weird numbers. We'll divide this by -2 because it's convenient, and it doesn't give us weird numbers. Okay. And I could divide this by 2 right now, but there's no big need to yet, and I don't want to introduce fractions any earlier than I need to. So I'm going to just leave that there. Okay, now I start the elimination process in reverse. I use this pivot here. Let me go ahead and box the pivots like I've been doing in that other video. Just in this one instance of the matrix. These guys are the pivots. They are now... they are still our tools for manipulating the rest of the matrix. 2 of them have been turned into 1, and 1 of them I'm going to turn into 1 at the end of the stage. Okay, so I'm going to take now twice, let's say, the second row, and then minus twice the last row. Okay, to get this guy. So what I'm doing here is, let's actually just blank out these guys. I'm going to rewrite from the bottom. The bottom is all set in stone, and now I'm going to take the bottom row of this guy and use it against the middle row. So, this guy's still going to be 1. 2 minus twice 1 is 0, which was the point. And then 6 minus twice 4 is -2. Okay, that's great. Now this guy is wonderful. It's y equals -2 is what that's saying. Can't get any simpler than that. Now I'm going to use this bottom row against the top row. That's nice because I just need to subtract the bottom row from the top row. This stays 2, of course, because it only has zeros below it. This stays 2 because it's bringing in a 0. It will be changed in a minute, though. This becomes 0 as desired, and 14 minus 4 is 10. Okay, very close to being done. And I did it again. Now I do undo. Okay. The control key. I claim the control key doesn't work very well on this thing. Okay. So now, let me blank these out because I don't have them yet. I'm rewriting the matrix with the bottom row and the middle row. They are absolutely fine. And now I'm just going to use the middle row against the top row. I'm going to use it to kill that guy. So I'm going to subtract twice the middle row. So I'm going to take the top row minus twice the middle row. Okay. The 2 isn't going to change because of that, because it's 0 is below it. 2 minus twice 1 is 0, which is why I wanted to do that. This guy's already 0, so it's not going to change. It's going to be 0. 10, let's see, 10, scratch work. 10 minus twice of -2. That's going to be equal to 14. 14. And now we're almost done. We just need to divide that top by 2. Turned out not to involve fractions because it's contrived because I wanted it to be that way. And so there's our answer. It's actually staring us in the face. Just purely with matrices, we've got to a situation where if we do convert that back to equations, it just says x equals 7, y equals -2, z equals 4. And there's nothing more to be done. So elimination takes us all the way to the answer. It's pretty cool how that works.